Organik fonksiyonel gruplu silanlar başlıklı sunumunu yapmak üzere Evonik şirketi satış müdürü Sayın Vildan Öztürk Ertekin'i kürsüye davet ediyorum.
My name is Vildan Öztürk Ertekin and I am the sales manager at Evonik and I am responsible for silica and silence product lines and I am responsible for Turkey. Today, as mentioned before, all of us are here to share our solutions and our ideas for more habitable future, and so I would like to show you the Evonik solutions in this trend. Firstly, I will briefly take through my presentation. After a short introduction about Evonik industry solutions for the mega trend resource efficiency, I will introduce you what is organofunctional silence. After that, I will tell you about the technical challenges being solved by organofunctional silence. Once we have identified the solutions, I will show you some examples for Dynasilan solutions. Finally, I will summarize my presentation, what we have presented, and I will be appreciated to answer your question end of this section. Maybe Evonik name is a little bit new for all of you, but our previous company name was Degussa, and it is very well known in Turkey. And the name is changed in 2007, and as Evonik, we are serving a lot of different industries. And now I will give some examples of these industries, like building protection. We serve building protection solutions, enable longer lasting infrastructure. Our solutions provide reduced need for rebuilding and significantly reduce need for maintenance. Another industry is coating industry. Our solutions improves the performance of new generation coating system like solvent-free and heavy-duty corrosion paints, and very important application is automotive industries. And energy, as everybody agrees on, we need new energy source, and one of these new energy source is wind power energy. Our products are very important to improve the performance of these windmills. They are used in the structure of the composites, in adhesives, and also in the structure of cables. Another new technology is solar power energies. Our products are also used in the structure of silicon wafers and in the layer encapsulating films, and again also in the cable formulations. And tires. Tires produced with the latest silica silent technology have up to 35% less rolling resistance than the conventional tires. So it gains us up to 8% reduced fuel consumption and also longer service time. Now, I will introduce you basically what is the organofunctional silence and the mechanism. Organofunctional silence are bifunctional molecules. What does it mean? As you can see, there are two main parts. The first part is silicon functional groups, and the second part is organofunctional groups. Silicon functional groups can react with the organic fillers, inorganic materials like fillers, metals, and glasses, and organofunctional groups, they cannot be hydrolyzable, but they can interact with the polymers, resins, and other matrix. And I want to say that these organofunctional silents are creating very strong bridge between inorganic and organic worlds. Now I will explain you the mechanism of high silence works. In the basic, it is three-step process, and first step is hydrolyzation. For this reaction, we need humidity, and at the end of the reaction, alcohol is released. As a result of this reaction, silanones are produced, and these silanones are intermediate for the further step of the reaction. In the second step, these silanones are reacting with the hydroxyl group of the inorganic substrate. And it is very important that when we decide to choose substrate, it has to have hydroxyl groups. It is very important. And finally, the organofunctional groups are interacting with polymer matrix. This reaction mechanism is very important to understand the silent mechanism. Yes, after introduction of the chemistry, now I would like to show you the examples of technical challenges can be solved by organofunctional silence. First example is silence can be used as coupling agent. As all of you that there are many products in our life produced with glass fiber or talc containing polyamide and polypropylene compounds. And for better mechanical properties, we need silence treatment. And here, I want to show you the electron microscopy photo of quartz unsaturated polyester resin. And as you can easily see, the structure difference with and without silane. Another technical challenge is hydrophobation. Hydrophobic pigments have better compatibility with nonpolar systems like polyethylene and polypropylene. Also, hydrophobation means reduced water uptake. It is very important challenge for humidity-sensitive applications. Another important technical challenge is pigment dispersion. Silence can increase the polarity of the pigment surface, so it can be easily added into the it can be added in the non-polar solvents. As you can see on the picture, we used iron oxide pigments, and you can see the example of with and without treated and untreated iron oxide pigments. With the treatment, we changed the polarity of the surface of iron oxide, and it became soluble in water. Last but not least, very important technical challenge is cross-linking. Very successful solutions for medium or low voltage energy cables and also hot water pipes can be successfully produced with using silence. And now I want to show you some pictures of examples in plastic industry. Here you can see treated glass fibers. Here you can see polyethylene pipes, cables, compounds, treatment of filler, composite like engineered stone, and example of photovoltaic encapsulating film. And after I introduce you our megatrend, I explain you the mechanism of the organofunctional silence. Now I will give you the examples and technical evaluation of dinosylan solutions. Here you will see the performance and resource efficiency over the time. In this section, when I explain this technical evaluation, daha rahat olacak herhalde. In this section, we will follow this graph when I explain you our technical evaluation. At the beginning, the expectations were so basic. These are coupling, adhesion, dispersion, compatibilizing. And to achieve this challenge, we have started basic monomeric silence. Very well-known trade names are dinosylan VTMO, vinyl-based monomeric silence, and dinosylan ameo, amino-based silence. But it wasn't enough. Market needed more performance product to compensate the need of new market, new technologies. And we need increased performance to answer these new demands. In this slide, I will show you the main, basically one main photovoltaic modules. There are 5 main layers, and silence are used in the formulation of encapsulating film, and it improves the adhesion of encapsulating film onto the glass and onto the backsheet. And for the performance of one photovoltaic systems, this adhesion is very important. So, to fulfill the increased performance like faster reaction, better processing, and answering new technologies, we produced new solutions with the name of CIVO and CFIM products. After growing technology, only performance itself became not enough. Our customer needed more resource-efficient solutions, and this is what we have focused on. In this perspective, we have generated new multifunctional oligomeric silence. Silane oligomers are produced by pre-condensation reaction with silane monomers in our reactors. In the formulation, we used same silane monomers or different silane monomers. This is why we call them multifunctional. They have at least 2 functional groups included in one molecule. What is the benefits? The benefits are significantly reduced VOC according to monomeric silence, their multifunctionality, and they are much safer products since oligomers are placed under the name of polymeric definition, and also with this oligomeric structure we obtained high boiling and flash points. One example in this concept product is dinosylan 9896. It has oligomeric structure, excellent hydrophobicity, reduced VOC. And about the application. Here we have looked at the technology of surface treatment of filler and pigments. The filler is fluidized in the mixing chamber, and treatment solution is put onto the surface of the filler. And the mixing equipment is heated up to certain temperature. It is around 60–80 degrees. The mixer is open system, so the additives which we have used and byproducts can be disappear. The big challenge is to reduce the loss of these active ingredients, especially like silanes, during the reaction, and reduce the generated byproducts. These are the reasons why silanes with high boiling point and reduced VOC are important. And our product, Dynasilan 9896, is a very good example for this application. In this slide, we made a comparison with untreated and treated titanium dioxide and the effect on the viscosity. We used 30% of titanium dioxide in paraffin oil, and we checked the Brookfield viscosity. And as you can see in the slide, there is dramatically reduction in the viscosity, and with this new oligomeric structure of product, we obtain the best results. With the usage of oligomeric silanes, as I mentioned, we obtained better solutions, better performance, like reduced VOC, safer handling, safer processing. But it is still not enough. We are working on nearly VOC-free systems. This means this product has to be more environmental, waterborne, and safety handling products. In this concept, we created new multifunctional silanes with concentrated, stable silanose group. And it is called Dynasilan hydrosil. These systems are almost VOC-free, waterborne, non-flammable, and as I mentioned before, it can have two different, or at least two different functional groups, and it means that you can obtain different functionalities in one molecule. Again, in the past, the addition of silanes in an open mixing system and in slurry system was not so easy. But with using these hydrosil products, filler surfaces can now be modified very easily in slurry system during production, like precipitation process. And also in the old system, as I mentioned, it is open system. With low VOC products, you can easily treat your filler or pigments. A very successful example is ultramarine blue for color master batch with Dynasilan hydrosil 2909. As we can see, this product gives excellent hydrophobicity, and it can be used effectively both in polar and non-polar matrix because of its multifunctionality. Again, here are some examples of our hydrosil products. And I'm almost end of my presentation. Up to now, we have discussed the solutions of Evonik Industries to support the new trend resource efficiency. I try to explain the chemistry behind silane technology and the technical challenge which can be solved by silane technology. And we have seen the technological trends over the time, like increased performance, VOC, and more environmental products. And we shown some examples of organofunctional silanes. And I have to say that we are very hardly working on this concept, and we think that our responsibility is not finished yet, and our efforts are continue. Please feel invited to contact with us if you have any challenges, any ideas to discuss this topic, and we would appreciate for this contribution. Thanks for your attention, and if you have any questions, end of the section, I will appreciate to answer them. Thank you.